Presentation results for Lending Club Investor Returns. Advanced Business Analytics Capstone Project by Wendell Moore. About our client, Lending Club. They provide the world's largest peer-to-peer lending platform where borrowers can obtain unsecured personal loans between $1,000 and $40,000. Investors can purchase notes backed by payments made on these loans. The investors can search and browse loan listings on the company's website and select loans that they want to invest in based on the information supplied about the borrower. Investors make money from the interest, whereas Lending Club makes money by charging borrowers an origination fee and investors a service fee. It is important to note, investors are exposed to risk and they need to understand the quality of the loans. Will a loan default? How much loss will be incurred in a given portfolio? These are key questions investors should ask when choosing which loan portfolios to invest in so they can dramatically reduce their risk exposure. For this project, an investment company is planning to invest $10 million with Lending Club. We have been hired as a consultant to help them choose the loans they want to invest in. The loan data was provided by Lending Club, and the following slides lay out our processing steps aimed at helping the investor choose the loans in which to invest their $10 million. To limit the scope of our project, the file provided contains only data from the year 2015 and only has 36-month loans for credit card debt. We begin by preparing the data for exploratory analysis in order to gain a better understanding of it. First, cleanse the data. Remove any irrelevant columns, blank or null data, as well as identify and remove outliers. Second, process the remaining data, providing the information to the investor to help them with their decision making. Data visualization is a vital tool to help communicate results clearly. See our plots from our data on the following slides. The graph to the right shows a distribution of interest rate ranges to the number of loans per each range. Notably, it shows that there's a large number of borrowers who have loans with interest rates between 7.72% and 8.32%. The plot on this page shows a relationship between the borrower's annual income and their interest rate. It shows that a large concentration of borrowers have an annual income less than or equal to $200,000 with interest rates greater than 5% and less than or equal to 20%. We use several different classification process models to determine if loans were good or bad, because even if a loan is bad, lenders can recover some of the money they lent. To find good loans, we only consider the loans that have status equal to charged off. Created a new data column called loss, which is the difference between loan amount and total payment. Split the data set into training and validation sets using a 60-40 split. This includes removing outliers and using several different regression tools with loss as the dependent variable. Based on the numbers obtained using these models, we are confident in recommending to investors that a profit can be made from loans our prediction models have classified as good. For the final part of our process, we use different cluster analysis models to help summarize the data and present an explanation of our results to the investors. First, we created 5 homogeneous groups, i.e. clusters, of loans using the statistics associated with these groups to estimate the performance of the loans and find the optimal investment strategy. Second, we built a simulation model in which we invested $2 million in each of the 5 clusters to find the expected total return after 1 year and the chance that the return will exceed $500,000. Lastly, we built an optimization model and allocated the $10 million across the 5 clusters, reporting the expected total return after 1 year and the chance that the return will exceed $1 million. Our conclusions to the investors are offered on the next slide. To the investor, our simulation model shows that expected total return after 1 year should be between $225,000 and $275,000. Percentage chance that return will exceed 0.5 million is between 0.45% and 0.55%. Using our optimization model, expected total return after 1 year should be between $235,000 and $287,000, with a percentage chance that return will exceed 1 million, being between 19.6% and 24.0%. This ends our presentation for the Capstone project. Thank you.